SCR can be made conduction. So we need to give the actual power supply, that is your anode to cathode power supply you are giving. In addition to that one, we should also give the gate current. We should also give the gate current through one more energy source called the EG. So EG is connected to gate, where it's going to give the power supply to gate, and it's going to generate the gate current IG enthalpy. So let us see how exactly it's working. This is block circuit diagram. This is what your characteristics. This is the characteristics. So I will explain that how it is. So it is like before IG has been given, this is what is working over. Once I give the IG, that is gate current, I keep on increasing that one. At one stage, IG is given, IG is going to be made the thyristor to work in conduction mode. All of a sudden, the voltage will decrease and your I values keep increasing over. I am keep on increasing the voltage, but nothing was happening. Then I fixed the IG value, my gate current value. That is, this is what the value. Some IG value, some IG is equal to, assume that 5 milliamperes. Assume. So current is measured in terms of the milliamperes. When I give my 5 milliamperes, immediately the voltage will come down and current will keep increasing over this. That is what is happening here. So now, with respect to the IG value, I was keep on giving, so current is not increasing. This is the voltage VBO, we call this breakdown voltage. As soon as I give the one value of IG, it comes back, the voltage is coming back. Voltage is all of a sudden it's decreasing. Previously it was some value, it's decreased. Then current is keep increasing. This is with respect to one IG. Assume that I am going to give one more IG, different IG, more than that. So, before giving it will be like this only. But if I give you one more IG, this may be some 5 milliamperes, that is IG1. This may be 7 milliamperes, IG2. Maybe. Okay? Two different IG values I am trying it out. And I may be giving one more IG, and this may be IG3, there is 10 milliamperes. With respect to different gate currents, your breakdown voltages keep decreasing and current is increasing like an exponential. So it is, you need to define what should be the gate current value so that your thyristor is going to work. It will be giving the current and voltage itself. For small voltage, it's going to increase. There is an experiment in your lab, thyristor characteristics, SCR characteristics. If you do this one, you will come to know how exactly it's working. Even though I keep on increasing the voltage, current was not increasing. But as soon as I give the gate current, small gate current, as soon as I keep increasing, all of a sudden it comes back and then current will increase over this. So you need to use 3 multimeters, one to measure the V, that is your voltage, one to measure I, and one to measure your IG value. 3 different multimeters you're supposed to use that. A simple circuit. This is this. And here we will be having 2 currents. One is IL, other is IH. 2 currents are there. In this I value, there are 2 low values of the currents are there. One is the IL, other is the IH. What do you mean by IL? It's a latch current, we'll call that. Latch current. IL is the latch current or latching current. IH is holding current. And IL is greater than IH. IL is greater than IH. That is what is required. Okay. So during reverse voltage, you are going to get the reverse bias. How the diode is going to work in the reverse bias, same way it's going to work over. Because anode is negative, cathode is positive. So it's a reverse bias. How the diode is working, the similar way you are going to get the same function you are going to get, even though you are going to give the gate current here. Even though you are going to give the gate current, it will be similar to your PN junction. The normal PN junction is going to work. That is We are going to have the forward avalanche current, forward leakage current, forward blocking region, and reverse leakage current, reverse blocking region. Everything comes into picture. Another 2 minutes I will take. I will complete this. Okay. VBO, forward blockage breakdown voltage, VBR, reverse breakdown voltage, IG, gate current, IL, latching current, IH, holding current. So here we will find different regions. Reverse blocking region. When you give the reverse voltage, when you anode and cathode has been reversed, you are going to get the reverse blocking region. Forward blocking region, when you give anode and cathode, they are in the forward bias. J1 and J2 are in forward bias, and J2 is in reverse bias. We are supposed to give the IG. Then based on that, you are going to get it. In this region, the anode is made positive with respect to the cathode, and therefore junction J1 and J3 are in forward bias, while the junction J2 remains the reverse bias. Hence, the anode current is a small forward leakage current. The region 0 to M, region 0 to M of the VA characteristics is known as the forward blocking region. See, where is the 0 to M? See here, 0. This is 0. This is M. Okay, 0 to M. What we are going to have, that is forward blocking region. We are going to come from this point to this point. We are going to get forward blocking region. 0 to N is there. 0 to N. Okay, forward leakage current we'll call that. Let us see what's going to happen. Forward blocking region. In this region, the anode is made positive and respect to the cathode, and therefore the junction J1 and J2 are forward bias, while the junction J2 remains reverse bias. Hence, the anode current is going. Now, forward conduction. Forward conduction, what happens? Whenever you give your J2 also forward bias, then it's going to come as the forward conduction. Okay. When the anode to cathode forward voltage is increased with the gate circuit kept open, avalanche breakdown occurs at the junction J2 at the critical forward breakdown voltage, and the SCR switches into a low impedance condition. Okay, high conduction mode. The forward breaking voltage is corresponding to the point M when the device latches on the conduction state. So this how exactly forward conduction comes into picture. You can note down. Anode current must be more than a value known as a latching current. The I value what we are having in the graph, I value, this should be more than the latching current. Anode current should be more than the latching current over there. Okay. In order to maintain the required amount of the carrier flow across the junction. Otherwise, the device will revert to the blocking condition as the anode to cathode voltage reduced. Anode to cathode voltage reduce reverse bias. Latching current is very important. Latching current is the minimum anode current required to maintain the thyristor on the on state. Minimum anode current required to maintain the thyristor on state. Thyristor is on off stage on stage conduction. So this is I, but this is IL. This IL should be minimum anode current required to maintain the thyristor in on state. Okay, vehicle accelerator ಕೊಡ್ತಾ ಇದ್ದಂಗೆ ವೆಹಿಕಲ್ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ನೀವು ಆಕ್ಸಿಲೇಟರ್ ನ ತುಂಬಾ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ ವೆಹಿಕಲ್ ಆನ್ ಆಗೇ ಇರಬೇಕು. ಆಕ್ಸಿಲೇಟರ್ ಇಸ್ ಫುಲ್ ಡೌನ್ ಮಾಡಿರ್ತೀರಾ, ವೆಹಿಕಲ್ ಆನ್ ಆಗೇ ಇರಬೇಕು. ಅದೇ ನೀವು ಕೀನ ಇಂಡಿಕೇಟರ್ ಇಗ್ನಿಷನ್ ಆಫ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಸ್ವಿಚ್ ಆಫ್ ಆಗ್ಬಿಡುತ್ತೆ. ಇಗ್ನಿಷನ್ ಆನ್ ಆಗಿದೆ, ನಿಮ್ ಆಕ್ಸಿಲೇಟರ್ ನ ತುಂಬಾ ಲೋ ಅಲ್ಲಿ ಇಟ್ಟಿದ್ದೀರಾ. ಸೊ ದಿಸ್ ಇಸ್ IL indicates the low current which is required to keep your thyristor on state. Immediately after the thyristor has been turned on and the gate signal has been removed. Gate na remove ಮಾಡಿದೀವಿ, gate signal remove, IG remove ಮಾಡಿಬಿಟ್ಟಿದೀವಿ. ಆದ್ಮೇಲೆ ನಿಮ್ಮ thyristor on state ಅಲ್ಲಿ ಇರಬೇಕು. thyristor on state ಅಲ್ಲಿ. That is what you are going to call this a latching current. ಇನ್ನೊಂದಿದೆ ನಿಮಗೆ holding current. Once the thyristor conducts, it behaves like a conduction diode and there is no control over the device. Conduction ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತಾ ಇರುತ್ತೆ. Device will continue to conduct because there is no depletion layer at the junction J2 due to the free movement of the carriers. If the forward anode current is reduced below a level known as the holding current, a depletion region will develop across the junction J2 due to a reduced number of carriers and the thyristor will be in the block state. ಏನಾಗ್ತದೆ, IL ಇಂದ ಇನ್ನೂ ಕಡಿಮೆ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತೀವಿ. IL is the minimum current required to keep it in on state. ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಮಾಡ್ಕೊಂಡು ಹೋದ್ರೆ there is one level called IH, that is holding current ಅಂತ. ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಮಾಡ್ಕೊಂಡು ಹೋದ್ರೆ, ಹೋಲ್ಡಿಂಗ್ ಕರೆಂಟ್ ಗಿಂತ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ ನಿಮ್ದೇನಾಗುತ್ತೆ, ಬ್ಲಾಕ್ ಸ್ಟೇಜ್ ಹೋಗುತ್ತೆ. The thyristor will be in the block state. We have an actual current called I, we have an IL, we have IH. IL is minimum current to keep the thyristor on state. IH is the current It's a holding current. Adikkinta kadame andre block state bottom. Okay. Holding current is the minimum anode current to maintain the resistance on the on state. The holding current is less than the latching current. The holding current is in the order of milliamperes and is less than the latching current IL. Milliamperes less than the latching current IL. So I'll stop marking. Okay, I'm going to stop it now because next is we are going to deal with the gate characteristics. There is one more question called gate characteristics.